Okay, welcome. This is the, I guess the key or the answers with explanations for this relative age dating worksheet, which was your assignment. The key here to the rock symbols, I will refer back to it. I'll scroll back up to refer to it only as it's relevant. But let's get down to the first one. So the first, here we go, the first figure, figure 1. We'll put it in order from oldest to youngest. Remember I said that I always suggest you work from oldest to youngest. Don't work from youngest to oldest. So the oldest, according to the law of superposition, is going to be C. And then we move up the line. We got E. Next is D. And that's usually as far as people get. And then get to A and B and say, well, what's the correct order? So for this one, you're lucky it could be either one. Okay, I think the best order is A, then B. But if you had B, then A, that is fine too. Let me just quickly explain why I think it's best described as A and then B. So we know that C, E, and D were layers that were there before A, which is basalt. That's an igneous rock pushed up through those layers. And if you imagine that B is not there currently, right? Pretend like B is not there. That makes D the surface level. You could stand up here on the surface of D. So if you were a person, you'd be standing right there, and B would not be there. And this molten rock pushes up, and the reason why it goes horizontal is because when it reaches the surface, it spills out onto the surface and becomes this sort of sideways flat feature. So I think it's A first, and then after that, B was deposited on top of it. It is also possible for you to have interpreted this as C, E, D, and B were all there, and then A pushed up through, and does push through a little bit of B. I mean, you can't argue that it does cut into B a little bit. So if you argue that, that's fine too. Now, if there had been little stars here, if there had been stars within layer B right next to this igneous intrusion, this molten rock, then that would confirm that it had to have been B first, then A. Because these little stars, according to the key, tell you what is a zone of contact metamorphism, which is basically when molten hot rock pushes up through pre-existing rock, that heat cooks the pre-existing rock just a little bit, just right next to it. Okay, which is why it's contact metamorphism. So whatever is in contact with that molten rock actually metamorphoses, turns into metamorphic rock. And so evidence of contact metamorphism would tell you that B was there first and then A pushed through. But as I stated, it could be either one in this case. Okay, next one. This one's a bit more straightforward, but it does have the contact metamorphism. So see the contact metamorphism stars here. So that tells us that we had E was there first, and then B pushed up through, cooking a little bit of this metamorphic rock. Okay, and then some erosion happened. So this line that I'll trace here, this is an unconformity. We know that some material was eroded away, and we can kind of figure that out because the tip of B has been cut off. So that tells us there used to be material above that was then eroded away, and now we've lost it forever. So after that, the layering is pretty simple. It's law of superposition. So we have, oh, excuse me, that shouldn't be B. It should be E, then B, then C, then D, then A. Okay, moving on to the next one. This one is deceptive. It's the hardest one if you don't know what to look for. So the correct order I'll start with is C, then A, then B. So if you're using your default law of superposition to start this one, that's actually the first mistake. So the bottom feature is A, and you think that might be the oldest, but you can see that the patterning is that of basalt, which is an igneous rock. And you also have the clue of the stars of the contact metamorphism. So that tells us that C was already here. A pushed into C, cooking it a little bit at the where it comes in contact with it. That's contact metamorphism. And then B, which is another type of basalt. They've only changed the color of it because you wouldn't be able to tell the difference otherwise. So B then cuts through both of them. So B is last. This one seems complicated, but there are no igneous intrusions. So really all we're dealing with is law of superposition and then law of cross-cutting with these fault lines. So B and E are faults, and therefore they are younger than anything that they cut into. So we have G here is the lowest level. Okay, so G is the oldest. And then we have in order C, then A. And I think that F was also here, and then B. So that's the first half. The earthquake happened after F was already there because B, this fault line, cuts into F. It is possible that this earthquake, again, if you think about, like, if you rewind time, erase everything above A. So F, pretend F was not there yet. I could stand here on the surface and look at where this earthquake had occurred. This is something called a fault scarp. This is where the surface of a fault is exposed above the ground level. So it's possible that that was the case, and then F was deposited in this area, but I think it's more likely that F occurred first and then was affected by the earthquake. So the second half of it works in kind of the same way. We've got to go to our H is the next level, the next layer, then D, and then we're at the same quandary as to whether it's I and then E or E then I. For the same reasons, I think that it's first I, the layer, and then E, the earthquake. Moving on to the next one. This is the last one? Yep, last one. So this kind of puts it all together. So we have some bent layers. Sort of discuss what that is and when it might have happened, because that's kind of important. I'll note it over here by a little star. So we have a igneous intrusion. This is more basalt, so we know that couldn't have happened first. It's pushing through D and H and A. So we know that C is older than D, H, and A. So D, H, and A would be first. The question comes, however, between C and G. C is this igneous intrusion, and G is this fault line. But if you take a look right up here, you'll see that is part of igneous intrusion C. And that tells you that the earthquake happened after C was already there. So C had to happen next, and then earthquake G. Now, before any of that happened, before igneous intrusion got pushed through, and before the earthquake occurred, these layers, which would have originally been flat, okay, because these two are sedimentary layers, they would have been flat originally, they were folded. And so I'm going to put a little blue asterisk in here, because this is where, between A and C is when that folding event would have happened. So it's worth noting in the context of, what was the actual history of this area. That's something that happened. So next, it's pretty simple. It's law of superposition straight through, FIBE. But again, if we're making a note anytime we have folding events, because that is a part of the geological history of the area, we'll just note that again. So I'm going to put that we know F, I, and B would have at one time been horizontal, but then it was tilted. So after this folding event, and then after F, I, and B were laid down, things were tilted once again. And then material was eroded to make this a nice flat line, and then E was deposited last. So these stars simply represent folding events or tilting events, like caused by tectonic forces. So I hope that helps, and you can check your answers and be ready for more challenging puzzles.